Hello all. Welcome back to my YouTube channel Rapid Data Tracks with Shubha. I hope you all are doing well. I know it's been long time since I have connected with you with other videos or other data engineering concepts, but I hope you can understand that there were many festivals in the middle and also I was stuck up with few work. But never mind. Again, I have come back with one of the most asked and the important playlist for the data engineering interviews, that is on data modeling. So let's start. Okay. So, what is data modeling? Data modeling is the process of organizing or structuring the data so that it becomes very easy for us to retrieve, store, or analyze the data. So, many have come to me and asked, do I need to learn HLD, LLD, load balancing, all those things? My answer is no to this because that will be helpful when you will be developing the system, but here we are not developing the system, we are working on the system that has already been developed and we are helping the people to analyze how the system works. For example, I am not working on building the Amazon website uh, and launching the products or launching the new features to Amazon, but instead I am working on like how Amazon can improve their business. So the system is already built. Now I'm trying to analyze the system. So as a data engineer, I'll be working on how can I improve the existing system. So in this way, you can think like it is a kind of a blueprint for the data, like how the architecture or architect plan before building the house. So this is the same way, like before launching the product we will be analyzing like how this product can bring success or how this product can be beneficial for any of the organization. So if I can say one of the product is selling most at this particular peak time, so this is the data am I analyzing. So in this case what happens is I will tell the organization that this product is in boom and I have analyzed with the system that you have built. So you can introduce more number of products with this or more number of product with this brand or something. So in this way, we'll be telling someone like how can we improve their system. So please be very sure, like we will be not learning high level, low level, all those things, but instead we will be learning how we can model the data so that we can help our organization to improve on the products that have already been developed. So for every successful system, take it as Amazon, Netflix, YouTube, whatever it may be, it starts with a solid data model. Without data model it becomes a mess. So that's why data modeling is a very important concept and it is one of the foundational concept in the data engineering domain. Okay, so before moving on, a very small concept like why data modeling is critical. I will just explain 2 points over here. One is for data engineers, any good model will ensure that it has efficient pipelines, it has clean joins, and also it will perform better. And also, one more thing is if the data is consistent and reliable, it is helpful for analysts to query the databases or also to put it into any dashboard and make a ad hoc query run on that. So I can just see the very good data model will result in better performance. Okay, I know you all need practical approach to solve interview questions on data modeling, and you might be wondering like why I'm taking all these theoretical concepts into picture and why I'm teaching all these things. But it also becomes equally important to understand the basics before moving on to the practical implementations. Don't worry, I will not drag it too much. I will just cover very important theoretical concepts and I'm trying to break down them in a very easy language so that everybody can understand, and then we can directly jump on to the practicals. So without wasting much time, let us try to understand core elements of data modeling. So the first one here is entities, attributes, and relationships. So first one is entity. Maybe you can think it as a table name like customer table, order table, product table, like this. Basically, entity is a real world object you want to store the data about. Like customer table will have customer information, order table will have order information, etc. So the next thing is attributes. For example, the customer table can have name, email, phone number, address, etc. And sometime order table will have uh, order id, date, amount, etc. And products maybe. So product table will be having product id, product name, price of that product, available or not. So these information. So basically, attributes are nothing but properties of that entity. For example, if customer is an table, if you treat it as an entity, then the attributes will be name, email, phone number, address of that particular customer. And next thing comes is relationship. So I can say like a customer can place multiple orders, or a customer can place one order, and at the same time one order can contain multiple products. So we are just trying to connect the entities over here. As I said, if I want to know which customer has ordered which product, then I would like to take customer id as an attribute from the customer table, and product id as an attribute from the product table. So if I join these two table, then I'll be getting which customer has ordered which product. So as I said, a customer can order the product. So this is how I'm trying to build the relationship between them. So basically, in the simple English, you can think it like entities are your nouns, attributes are your adjectives, and relationships are your verbs. Okay, the second core element is keys. So in this, we will discuss about primary key. So this primary key is an unique identifier for each record in a table, and the rule here is it cannot be null and it must be unique. For example, if I take a customer table, then customer ID cannot be duplicated because every customer will be having a unique customer ID, and it cannot be null as well. So this is how we identify which can be a primary key. Okay, and the next thing is foreign key. Foreign key is used to connect one table to another table. For example, I want to understand which customer has placed which order. So in that case, from the order table, I can make sure order ID is a primary key, and I will introduce customer ID over there, and I will take the reference from customer table. So then I will declare this as a foreign key. So this you might see in the below query as well. I have declared customer ID as a foreign key and referencing that to the customer table. So this is how foreign key works. And the next thing comes is surrogate key. So this surrogate key is often an artificial key, and this will come into picture when natural keys are not good enough to be declared as a primary key. So what happens is, for example, imagine like we have a email table, and that email table contains only email address and the password. Okay, so this we are trying to log in and match the email id and password. For example, what can I make here as a primary key? Because person can change email id anytime, and a person can change password also anytimes he or she wants. So in this key, deciding primary key becomes a very difficult task. So what we do is, usually we will create some column as an auto increment column or a GUID column. So GUID will be any randomly created GUID, and auto increment will be like as soon as the record gets inserted, the ID will get incremented. So if you create any column in such a way, then we name it as a surrogate key. So instead of making email as a primary key or password as a primary key, I can introduce any one of this like email ID or something, some GUID column, then I can call it as a surrogate key. Okay, so moving on to the next thing, that is how many instances of one entity can relate to another entity. So the first thing is one to one. So here each entity has one related entity. So for example, one person can have only one customer ID. If I am a customer to Amazon, then how much ever orders I place, how much ever products I buy, but my customer ID will remain same. So that is where one person will be having only one customer ID. So this we call as one to one. And the next thing is one to many. So this is like one entity is related to many others. For example, one customer can place many orders, but whether though I place 10 orders, 15 orders, 20 orders, but the customer ID is going to remain same. So with the same customer ID, I can place n number of orders. So this is where one to many comes into the picture. And imagine many to many. So here you can see many entities relate to many other entities. Okay, for example, uh, one product can be present in the multiple orders, and an order can have multiple products. For example, if I am going to buy a laptop, then other person may also buy a laptop. So if you leave about the customer and just think about the orders and the products, so here one laptop is being ordered by many, and also many laptops are going to be there in one order. For example, if I take two laptops, then two laptops can be present in one single order. And also if I take one laptop and someone takes some one laptop, so both laptop brands are same, in that case I can say many orders have many products. So in this way I can say a product can belong to many orders, and an order can have multiple products. So in this way, many to many relationship is defined. And usually we make some concept here called as a bridge or a junction table. So usually we create this table to resolve this many to many relationship. Don't worry like what is a bridge or a junction table, I'll be discussing them in the upcoming slides. Okay. Okay, so now let us discuss on the type of models. So we are here, we have three types. First one is conceptual model, second one is logical model, and third one is physical model. So let us study one by one. We'll take a simple example here. So let's take a e-commerce example. As I said, we'll be having customer table, order table, and product table. So now let us try to elaborate these models, and I'll tell you what will fit into each model and where each model will come into picture. Okay, so first thing is conceptual model. So here this is a high level view. Maybe you can just treat it as like it shows the bigger picture of how data flows between entities. As our entities are customers, orders, and products, I can say a customer places an order and order contains products. So this is just defining the relationships. Okay, this is a very high level view on what the system does. And next thing goes is logical model. So here what we do is, in the conceptual model, we just learned if we have three tables, how they are related to each other. So for example, customer, product, and order. So customer can place a order, and order can have a product. So this is how we got to know how they are related. But let's dig more into that, so that we can add more details or information to each of the entity, that like what it holds. Okay, for example, adding the columns, maybe for example, for the customer table I can add customer id, name, email. And for orders table I can add order id, order date, total amount, etc. And for the product table, same thing, product id, product name, price. So here I can say customer id connects customer and orders table, and order id connects with product table, just to define like which order contains which table. So in this way logical model will works. So physical model is one step ahead of logical model. Here we just got to know in logical model that customer id, customer name, and customer email will be present in the customer table. But what is the type of that? For example, name, can I keep it as int? No, because name cannot be numbers. So what I'll do, name I'll declare it as a string type. So it is a more detailing. So it might be like adding the auto indexing, or it might be adding the data types to the columns, or defining your primary key, or foreign key, like this. So it is just the actual implementation of the database that you have designed. So basically you have to understand conceptual model is just like a discussion. I want a system where person will come and order, so these are the products, so how they are related. But when it comes to logical modeling, you have to understand, okay, if a person comes and order, how can I track about person, so that I can have a person id, person name, and a phone number. How can I track the order? Because I'll be having order ID and what all products they have ordered. So this is how the next discussion goes on. And again, if I come back to the actual implementation of this, so this is where your physical model comes into the picture, and you will actually define which is the primary key, which is the unique key, which is the surrogate key, what are the types of data, so how we are going to index this, and are we going to partition any of the data. So here I have just shown an example like how we can create and assign keys or data types to this. But basically the physical plan depends on like how the requirement comes on. Basically this is how the three models comes into the picture. I think so I have tried myself to the best, and have given myself 100% so that I can explain you in a very easy language. Hope it's clear here. And also, as I said, we will discuss on the bridge table, and basically how it looks and how we derived it, kind of a thing. So let's look on to this. So now what you are seeing is a bridge table. This is also called as a junction table or a association table. This is help to resolve many to many relationship. So what it basically does is it will bring back many to many to one to many. So basically it will convert many to many to one to many. So how it can be done, you can see here I have taken order id as a foreign key from the orders table, and product id as a foreign key from the product table, and just I have introduced some quality quantity kind of a thing. And so I have declared both order id and product id as a primary keys over here. So there is no constraint like there should be only one primary key. You can have n number of primary keys as well. Just the thing is it cannot be duplicated and it cannot be null. That's it. So this is how the bridge table looks like. So now you might be having question like how this can solve a query to me. So if you can see here, one order can have multiple products. So I can say now directly like initially I used to say like a product can belong to multiple orders, but now I can say one order can have multiple products and vice versa. One product can be present in multiple orders. So I have defined it very clearly now. So now if you say one order id, if I just go further and if I write the query on distinct order ids, then it will show me the order id and how many products are associated with it. So if you want, you can do a group by, so easily, without doing much calculations or without messing up with the data. This junction table will help us to solve the real world problem, that is like many to many to one to many. So this is how the bridge table helps. Hope you have understood this. If not, no worries. Going forward in our playlist, we'll be using these concepts, and that time with real world example, it becomes more clear to you. Okay, I wanted to cover a few more concepts, but I think this video is going to be too long, so I will cut it here. But I will make sure that I will cover other concepts in our next video, and then we can get started with the actual implementation. Just a quick recap, we can call, before closing this. In this video, we saw what is the data modeling, why we need it, why it is critical kind of a thing, and also we saw like how it acts as a blueprint for any of the system, and also we broke it down to core elements of the data modeling. It might be entities, attributes, keys, relationships, etc. And also we tried to connect the dots between the types of data model, and also we understood the importance of the bridge table or the junction table as well. So hope it was a clear, and please don't forget to like, share and subscribe. I'll bring more such amazing videos for you all. Thank you so much for watching. Stay tuned.